SpaceX has just revealed calculations that stun NASA officials. They can transport 100,000 metric tons to the moon using 1,000 Starship launches, the exact same number already planned for Mars missions. While NASA designs small lunar outposts for 4 astronauts, SpaceX is planning something unprecedented, a permanent lunar city. The numbers are real. Each Starship can carry 100 tons to the moon. The technology exists, but the implications are staggering. We're looking at humanity's first extraterrestrial civilization, not just research stations. Let's dive right in. The cost difference reveals why SpaceX thinks so differently. Traditional space missions cost $10,000 per kilogram to launch materials to the moon. Starship drops this to under $100 per kilogram, a 99% reduction that makes lunar construction economically realistic for the first time. This dramatic cost shift explains everything. NASA carefully budgets for small, temporary missions because every kilogram costs a fortune. SpaceX can think in terms of entire cities because their transportation costs make large-scale construction feasible. The economic barrier that limited space exploration for decades just disappeared. NASA identified 13 potential landing zones near the lunar South Pole, but SpaceX zeroed in on the Shackleton-de Gerlache Ridge for compelling reasons. This location offers 3 critical advantages: permanent shadow regions containing water ice, nearly constant sunlight for power generation, and direct line-of-sight communication with Earth. Water ice solves multiple problems simultaneously. It provides drinking water, breathable oxygen through electrolysis, and hydrogen fuel for rockets. Constant sunlight eliminates the power storage challenges that plague other lunar locations. Earth visibility ensures reliable communication without satellite relays. It's prime real estate, lunar style. Here's where the plan becomes genuinely revolutionary. Every kilogram produced on the moon saves 61 million joules compared to shipping from Earth. Enough energy to power an average home for 17 hours. This energy savings makes local production not just practical, but essential. Lunar regolith contains everything needed for construction: oxygen, iron, titanium, silicon, magnesium, and aluminum. These elements can be processed into metals, ceramics, glass, and structural materials using proven technologies. NASA's hydrofluoric acid leach system already demonstrates how to extract usable materials from regolith. The Redwire Regolith Print project proved 3D printing works with lunar materials in space conditions. The manufacturing starts immediately. Automated systems arrive on early Starship flights and begin producing basic materials while human crews are still on Earth. By the time astronauts arrive, construction materials are ready and waiting. The building sequence follows a logical progression. First priority: landing pads made from melted regolith using concentrated sunlight through Fresnel lenses. This isn't theoretical. The European Space Agency's PAVER project validated the technique using simulated lunar conditions. Landing pads aren't luxury items. They're survival necessities. Lunar dust particles are microscopic glass shards that damage equipment on contact. Apollo 17 crews faced equipment failures from dust coating. Soviet Luna 2 rover died from dust-induced overheating. Each unprotected landing blasts tons of abrasive particles across the construction site. Paved surfaces prevent this destruction before it begins. Roads come next, connecting landing areas to construction sites. These aren't for convenience. They're essential infrastructure. Smooth, dust-free pathways protect rovers, equipment, and eventually people moving between facilities. Each road extends the operational radius and enables larger construction projects. NASA's planned habitat demonstrates sophisticated engineering: a 7.8-meter-tall, 6.5-meter diameter inflatable structure that fits in a 5-meter rocket fairing. The design includes a metallic core, rigid lower section for equipment access, and multi-layer protection against micrometeorites and temperature extremes. But SpaceX's vision scales beyond single habitats. Multiple structures create neighborhoods connected by pressurized walkways. Specialized buildings serve different functions: workshops for manufacturing and repair, laboratories for research, recreational facilities for psychological health. The result resembles urban planning adapted for the most hostile environment humans have ever tried to inhabit permanently. Solar power works perfectly during lunar day, but lunar night lasts 14 Earth days. Battery systems capable of powering a city for 2 weeks would consume dozens of Starship launches just for energy storage. The solution? Nuclear reactors. NASA's acting administrator Sean Duffy targets operational lunar reactors by 2030. These aren't experimental concepts, they're proven technology adapted for lunar conditions. Nuclear power provides continuous, high-output energy regardless of solar conditions. Unlike Earth applications, lunar reactors operate in vacuum with no atmospheric contamination concerns. Nuclear power enables industrial operations that transform the lunar economy. Instead of rationing energy for basic survival, abundant power supports manufacturing, communications, life support, and expansion activities simultaneously. The moon offers unique manufacturing advantages impossible on Earth. Near-vacuum conditions enable ultra-pure metal production without atmospheric contamination. Perfect crystals grow in low-gravity environments. Pharmaceutical manufacturing benefits from sterile conditions and precise temperature control. Extreme dryness creates electrostatic effects useful for material handling and sorting. The stable lunar surface provides vibration-free platforms for precision manufacturing. Variable gravity between surface operations and orbital facilities enables specialized production techniques. These aren't just technical curiosities. They represent export opportunities. Lunar manufactured products command premium prices on Earth due to their unique properties and production environment. The moon transforms from expensive destination to profitable manufacturing hub. SpaceX plans 1,000 Starship launches to Mars over roughly 26 months during each launch window. Applying this proven timeline to lunar operations means delivering 100,000 tons in just over 2 years. Compare this to NASA's approach. Artemis 3 lands 4 astronauts for maybe 1 week. Artemis Base Camp houses 4 astronauts for maximum 30 days. The pace difference is staggering. NASA thinks in terms of decades to establish permanent presence. SpaceX proposes jumping directly to city-scale operations within years. The timeline acceleration comes from treating lunar development as industrial construction rather than scientific exploration. This plan fundamentally shifts international space dynamics. While nations spend billions developing small lunar missions, a private American company prepares to build the first permanent settlement beyond Earth. China's lunar program focuses on sample returns and robotic missions. Russia emphasizes limited partnerships and scientific cooperation. Meanwhile, SpaceX prepares for permanent occupation. The implications extend beyond national prestige. Resource extraction rights, territorial sovereignty, and space governance frameworks all become urgent issues when permanent settlement becomes reality. Current space treaties assume temporary scientific missions, not permanent cities with industrial operations. A lunar city needs everything from food to electronics. Initially, these come from Earth at premium costs, but local manufacturing gradually replaces imports with lunar production. The economic evolution mirrors historical frontier development, except this frontier lies 238,900 miles away. Tourism becomes economically viable once infrastructure exists. Initially expensive, costs decrease as operations scale and efficiency improves. Permanent residence creates service economies supporting both tourism and industrial operations. Economic sustainability emerges through diversified lunar industries rather than dependence on Earth support. Radiation exposure presents the most serious long-term health risk. Unlike the International Space Station's protection within Earth's magnetic field, lunar residents face constant cosmic radiation and periodic solar particle storms. City design must incorporate radiation shielding using local materials or underground construction in natural lava tubes. Medical independence becomes critical 238,900 miles from Earth hospitals. Surgery, pharmaceutical production, and emergency care must function with complete self-sufficiency. This requirement drives minimum population threshold needed to support specialized medical professionals and comprehensive healthcare facilities. Communication delays average 2.6 seconds round trip to Earth. Real-time collaboration becomes impossible for time-critical operations. Lunar cities must develop autonomous decision-making capabilities and independent management systems for emergencies and daily operations. SpaceX's lunar city represents more than ambitious engineering. It demonstrates technologies, economics, and social systems necessary for human expansion throughout the solar system. Success validates the approach for Mars colonization and asteroid mining operations. Resource extraction techniques, closed-loop life support systems, and off-world manufacturing capabilities developed for lunar operations become the foundation for humanity's multiplanetary future. This single project could establish the template for human civilization beyond Earth. SpaceX's lunar city represents more than ambitious engineering. It demonstrates technologies, economics, and social systems necessary for human expansion throughout the solar system. Success validates the approach for Mars colonization and asteroid mining operations. Resource extraction techniques, closed-loop life support systems, and off-world manufacturing capabilities developed for lunar operations become the foundation for humanity's multiplanetary future. This single project could establish the template for human civilization beyond Earth. This is exactly why SpaceX's plans shocked NASA. It's not about building one city on the moon. It's about proving humanity can build sustainable civilizations anywhere in space. Every technology, every process, every lesson learned becomes the blueprint for Mars, asteroids, and beyond. NASA's stunned reaction wasn't about the engineering. They know Starship works. It was realizing that while they've been planning careful steps, SpaceX is preparing to leap directly to permanent settlement. The space race just shifted from national prestige to species survival. The timeline is accelerating fast. Starship's first lunar cargo missions launch in 2026. NASA's nuclear reactors target 2030 operations. China announced their permanent lunar base plans. The next 5 years determine everything. We're witnessing the birth of humanity's first extraterrestrial civilization. This lunar city becomes a testing ground for technologies that will take us to Mars and throughout the solar system. It's the most significant step in human evolution since we first left Africa. How do you think this lunar city race will change international cooperation in space? Will nations compete for the best locations or work together? Space Hub brings you the space developments that shape our future. If this analysis helped you understand what's really happening with lunar colonization, hit that like button. Subscribe and ring the notification bell so you never miss our deep dives into space breakthroughs. Share this video with anyone interested in humanity's next chapter. The future of our species is being written right now, 238,900 miles above our heads. September 11th marked Russia's 300th mission to the ISS. But behind this milestone lies a crisis that could change space exploration forever. RSC Energia, the legendary company behind Soyuz spacecraft, just admitted something shocking. They're facing bankruptcy with $2 billion in debt. Their CEO warned it would take a miracle to save the corporation. Sanctions have crippled rocket engine production. Critical components are running out. This isn't just Russia's problem, it's NASA's nightmare. For decades, Soyuz has been the backup lifeline for astronauts. If Energia collapses, NASA becomes completely dependent on SpaceX alone. No redundancy, no alternatives. What happens when something goes wrong? Putin himself had to intervene, but is it too late? Let's dive right in. Here's what RSC Energia's CEO told his employees on August 26th, and why it sent shockwaves through NASA headquarters. The company behind humanity's most reliable spacecraft just confessed they're drowning. Debt jumped 17% in 6 months to 168.4 billion rubles. They can't pay salaries on time. Major contracts are failing. The CEO's exact words? It would take a miracle to save this historic corporation. This financial collapse didn't happen overnight. It started with a calculated political move that backfired spectacularly. Remember when Russia stopped selling RD-180 engines to America in 2022? That move was supposed to hurt the U.S. space program. Instead, it destroyed Russia's own aerospace industry. Those engines were Russia's golden ticket, millions of dollars per unit flowing from ULA's Atlas V program. When that revenue stream vanished, Russia lost critical funding just as Western sanctions began choking off their supply chains. The technical reality became brutal fast. Modern rocket engines require materials Russia can no longer access, specialized titanium alloys, radiation-hardened electronics, advanced polymer composites. The January 2025 sanctions targeted over 150 entities tied to rocket production, including the Central Research Institute for Special Machinery. Without these components, Russia's most ambitious project ground to a halt. The RD-171MV was supposed to be the world's most powerful rocket engine, their technological crown jewel. Today it sits incomplete, a symbol of how quickly technological isolation can destroy decades of progress. This engine shortage created a ripple effect that reached the highest levels of Russian government. September 5, 2025. Putin makes an unscheduled visit to the ODK Kuznetsov plant, one of Russia's last functioning engine manufacturers. This wasn't a photo opportunity. When world leaders start personally overseeing rocket engine production, you know the situation has spiraled beyond normal diplomatic channels. Putin's message was direct. We must ensure continuous renewal of booster engine production capacity. The subtext was even clearer. Russia's space program was dying, and the president himself had to intervene to save it. But presidential visits can't solve supply chain problems or replace sanctioned materials. The engine crisis was already claiming its most visible victim. The NK-33A engines that power Soyuz 2.1V rockets ran out completely in February 2025. No more engines means no more launches. Russia's most reliable launcher just became space junk. This matters enormously for NASA because Soyuz has been America's insurance policy for over 2 decades. When the space shuttle program ended, Soyuz kept American astronauts flying. When SpaceX faced delays or anomalies, Soyuz provided the backup. RSC Energia builds both Soyuz crew capsules and Progress cargo ships, the backbone of ISS operations.